Jai Jayendra, Namaste and welcome to my channel. Today we are going to solve the 99th question of the problem solving series and the 9th question of the topic tree. The difficulty level for this question is medium and this question has been answered in Microsoft, Amazon, Flipkart, Walmart, Dell, Make My Trip, Acolyte and many other companies. Vertical tree traversal. In the previous question we have discussed the top and bottom view of the binary tree. Here we will do the vertical traversal of the binary tree. We have already done uh, label order traversal. We've used the depth first search traversal also indirectly, and label order is by breadth first search traversal, the horizontal traversal. Now here we need to do vertical order traversal. Okay, so that means like this if we travel. So here vertically we see, okay, 4 we have got, and now here we have got 2. In this vertical order we have got, so this 6 will be part of this. This 6 comes here. This includes this 6. This 6 is here. So this is in the same line, right? I discussed the integer number line. So in this one we have 4. In this is minus 2 index, minus 1 index. This is 0 index. This is 1 index. This is 2 index. This is 3 index. Okay. So 4 to here we have 1, 5, 6, and then in the first order we see that we have 3 and 8. In the second we have 7, and in the third we have 9. Okay, third in this integer number line. Okay, so the total the traversal would be 4, 2, 1, 5, 6, 3, 8, 7, 9. So it's not a view that we can't see beyond 1. If we watch from top or bottom, we can't see the beyond thing. We will include all the things, like we are traversing. We need to visit, in traversal you visit all the nodes. Okay, so this way we will get our answer. We will visit from the leftmost to the rightmost node vertically. Okay, this would be the label, right? So you know, from the root, if we go to the left, we go to the direction goes -1. Again left, again we decrease -1. If we go right, we add the +1 direction. So in that way we will have the direction either 0, -1, -2, -3, and then we'll start from the least value, the most negative value, to the most positive value, and whatever node value we get, we'll add it, and then we'll add it to our vertical traversal vector. Okay, so let's code it. It's very simple. What we will do, we will do a traversal that we did for top view of the binary tree, but now we will take a map of integer, and the output would be a vector of integer, because we will store all these values. Okay, like 1, 5, 6, all these 3 and 8, all these 3 will be storing for index 1s. Like for example, this one will have mp1 is equal to 3, 8. Okay, like this. mp0 equal to 1, 5, 6. Okay, mp this will be -2. This is -2, -1, mp -1, mp0, mp1, mp2, mp3. So we'll have this whole thing. Then we can traverse this map and then add these values. Let's code it. It's simple, right? So we'll have vector of int, say result. Okay, if we see that root is equal to null, we will return an empty vector. Okay, we take a queue of 3 node strict and the index value. Okay, then we take a map of int, vector int, we store the vector mp. Now we insert the root and make pair. Okay, we'll insert root and the 0 integer this thing value. Now we have inserted this. So while q not equal to null or not q dot empty, while the q is not empty, that time we will do this, store this value here, pair of strict comma int node equal to q dot front. Will pop the q. Okay, then what do? We will see, we will add this value mp, this node dot second, the index, this one, node dot second, this 0 dot push back, will push this node dot first value. Okay, this one, we will add it here. Now we will do that same thing, that if node dot first left is not equal to null, we will push q dot push node dot first left. We push this node and the label minus this node dot second, whatever is label is there, node dot second, we will decrease it by -1. We are going to the left side. Okay, if node dot first right not equal to null, okay, then we do a q dot push node dot first right, and then node dot this what is this second plus 1. Okay, we add this. When we add right, we add the this integer value, this label, and then yeah, we are done with this. We pop the q. We have got this insertion of the pair of this, right, node dot first dot left and node dot first right, and second -1 and plus 1 as 1. Now what do? We just traverse the map for auto, and auto it is equal to mp dot begin it not equal to mp dot end it plus plus. Then what do? For I equal to 0, I less than it dot second dot size it plus plus. We add result dot pushback till this size is not all the elements of that index value. We will add here result dot pushback it second I index, all the index will push, and yeah, so this will be done, and then finally will return result. Okay, I know you have understood this. If you have any doubt, please check out the previous video how we have done top view and bottom view. You'll have the idea. So this is just the difference, that we take a vector of int instead of this and keep on adding all the values here. Vertically traversal, we will visit all them and add it to a resultant vector. Okay, the link to the question is given in the description. Please try it yourself and then come to my code walkthrough section. Here is the code walkthrough of the 99th question of the problem solving series in the Geeks for Geeks platform. Vertical tree traversal. You can see the example. We have discussed the same example. Okay, so you can, this is the traversal A, B, C, D. They have defined this like this, and this is the traversal, and then they have added the whole things 4, 2, 1, 5, 6, 3, 8, 7, 9 as the vector, and that they have returned. Let's look at the code. The code is the same that we have just discussed. You can see the code. So I don't think I need to do code walkthrough. You would have understood it directly. You can just check it while trying if you have made any mistake or not. Okay, I'll just directly submit this. So the time complexity would be order of n, and q we have taken, so space is order of n as well. We'll be storing all them into the vector. So yeah, see you all soon in the next video, where I'll be explaining the 100th question of my problem solving series and the 10th question of the topic tree. Jai Jinendra.